Now that we know how to differentiate the exponential function and the natural logarithm, I want to revisit our derivation of the power rule. So previously, we looked at n being an element of the natural numbers, and we derived that the derivative of x to the n was equal to n times x to the n minus 1. So the derivation was for n equals 1, 2, 3, etc. We know it's true when n equals 0 because the derivative of a constant is equal to 0. We proved that it's true for n equals 1/2. And for homework, you did some other values of n. But what I want to do now is prove it for real numbers. So for the exponent p, an element of the real numbers, I want to look at the derivative with respect to x of x to the p. We can do that by using the exponential function and the natural logarithm. So we can write that as the derivative of the exponential function of the natural logarithm of x to the p, because the exponential function and the natural logarithm are inverse functions. And then we can write that as the derivative of the exponential function of p log x using the property of the logarithm. We can go ahead now and differentiate. We know the derivative of the exponential function is the exponential function, and then we can use the chain rule to multiply by the derivative of the inside. So this becomes the exponential function of p log x times the derivative of the inside. The derivative of p log x is p divided by x, because the derivative of log x is 1 over x. This exponential function then is just x to the p. So this is equal to x to the p times p divided by x. So finally, we get p, and then x to the p divided by x is just x to the p minus 1. So what we've shown then is that for all real exponents, we have the power rule. d dx of x to the p is equal to p times x to the p minus 1. We may have always suspected that this is true, but using the exponential function and the logarithm, we have now proved it. I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.